Alrighty, folks. Can I ask you to stop talking, please? We're going to start by taking questions from the assignment from last time. Are there any things here that we'd like to talk about? Gabe? Okay. Does anybody have a specific one from 11 through 14 that they want to deal with? Lynn? 14? Is that okay with you, Gabe? Okay. All right. So 14. This was the given information. Now, the directions say that two triangles can be formed, solve them both. I'm just going to go over how I know there's two triangles going on here, just for the sake of argument. Now, I know the direction already kind of, you have that and you don't have to think about it, but what I'm looking for the possibility of having two triangles, the given angle has to be acute. Well, you have to have a SSA situation where the given angle is acute and the side that's opposite the given angle has to be less than the other side that's given. Oops. Which is what we have going on, right? Because side B is the smallest of the two given sides. That's the side opposite the angle. Okay, so this is the ambiguous case situation, which tells me I'm either going to have 0, 1, or 2 triangles. We don't know which one right away. To figure out which situation we'd be in, I'm going to use the law of sines. So I'm going to do sine B over B equals sine A over A. I'm then going to cross multiply and divide to get the sine A by itself. And I'm going to look at what the number is for 11 times sine 57 over 10. If that number is less than 1, I have 2 triangles. If it's equal to 1, I have 1 triangle. And if it's greater than 1, I have 0 triangles. So it all kind of depends on whatever that number is for the sine of A. Is this so far so good? Again, this is all stuff that you didn't really need to do because the directions told you already that there was 2 triangles. But this is, I think, the most difficult part of this chapter, so I just wanted to make sure we go through and kind of refresh and do one more time how I can tell whether I'm going to be getting 0, 1, or 2 triangles. So this number came out to be 0.99 or 0.922. Since that's less than 1, I know I'm in the 2 triangle situation. So far, so good? Okay. So what I'm going to do is I'm just going to make some notation here. So I'm going to just make a place for my answers for triangle 1 and a place for my answers for triangle 2. Now in both situations, the given information is still true, right? So in both triangles, the information given to me in the problem is there. That doesn't change. What's going to be different are going to be the values for angle A, for angle C, for side A. Oops, I'm sorry, we have no side A. I meant side C. Okay, so those numbers will be different for each of the 2 triangles. Okay, so I'm going to do the work for one triangle on one side, and I'm going to do the work for the other triangle on the other side, just so it's organized. If you go back and look at this or whatever, it makes sense as to what's going where. Is that okay? All right. So using the law of sines, as I had before, I'm basically going to be looking at this part, and I'm just going to take the sine inverse then of both sides to get angle A. And I'm going to put this answer with triangle 1. It doesn't really matter which triangle you put this answer with, but for the sake of argument, I'm going to put it here. So when I put that into my calculator, I get 67.3 degrees. And maybe just to be clear, I'm going to put a subscript of 1 and 2 on these variables, just so it's a little bit easier to tell what's going on. The ones for triangle 1, I'm going to put a subscript of 1 on, and the stuff for triangle 2, I'm going to put a subscript of 2 on. Just for this specific reason. So for triangle 2, I can find angle A by doing 180 minus my answer for triangle 1. And that will always be the case. That angle, the first angle we find, is always going to be the supplement of the angle, that first angle from the other triangle. So 112.7. Everybody okay there? The rest of this now is fairly easy. So I can find angle C1 by just doing 180 minus B minus A1. And angle C2 by doing 180 minus B minus angle A2. All right, just doing the triangle sum theorem. Since we know 2 of the angles, it's easy to find the third one. So 180 minus 57 minus 67. That's 55.7. And then 180 minus 57 minus 112.7 is 10.3. Everyone so far so good there? Okay. The last thing we have to do is find side C in each of the triangles. So to do that, I'm just going to use the law of sines again. So I'm going to say sine B over B was the short one, equals sine of C, which in this case was 55.7 over C1. When I cross multiply and divide, I get 10 times sine 55.7 over sine 57. When I go to the calculator, I get 9.85. Well, I guess I've been rounding everything else to one decimal place. I'll just call that 9.9. And for this problem, again, I'm going to do this the same way. I'm going to do sine B over B equals sine C over, oops. Oh my gosh. Did I just screw that up? No, okay, I did that right. Okay, never mind. Over C. I thought for a minute I used angle A instead of angle C, but it was fine. I did use angle C. You ever have one of those moments of panic where you just are like kind of in cruise control and you're like, wait a minute, did I just screw that all up because I wasn't really thinking about it? Yeah, that's what just happened to me. Okay. Is this okay, Lynn and Gabe, what we're doing? We're following everything okay? Yes, of course. Yeah, no problem. So 2.1 is my answer there. Sure. That's as far as I need to. I don't think there's anything below that, right?
Yeah.
Okay. Who else has questions from this? Again, this was pretty representative of, I think, the most difficult kind of question that we can run into in this chapter, which again isn't so bad, but you do need to do a little bit of practice with this. Those of you that skipped 11 through 14 or kind of did a halfway job of it where you didn't find all the parts, I would recommend going back and taking a second pass through those, as these are they're not difficult once you've kind of got the hang of it, but a little bit of practice really, I think, goes a long way to making sure that we're clear as to what we're doing here. There's a lot of moving parts kind of going on, and making sure you're keeping everything organized and you're using the right angles for the right triangle to do what you need to is important. And it's easy to kind of get that turned around the first couple of times through. So, okay. Other questions from this homework that we want to talk about? 13. Okay. So this is that same situation where I'm going to end up with two triangles. For the sake of time, I'm not going to go through and verify that there are indeed two triangles again. I'm just going to go straight to the assumption that I have two triangles and solve those two triangles. Is that okay? Okay. And realize that in 5 through 10, you're basically doing the same thing that I did to the start of that one. But I felt like it was, again, good review to kind of just run through that one more time. And again, I'm going to use like a little subscript here on these, just so I can kind of make sure I'm keeping things straight. Sound good? Sure, of course.
Perfect.
That's actually better.
Yeah, let your eyes adjust. Okay.
All right. So I'm going to then use the law of sines to solve for angle A1. So I'm going to say sine C over C is equal to sine A1 over A. So here I'm going to cross multiply, divide, and take the sine inverse kind of all in one step. Is that okay, Gabe? Okay. I just want to make sure that at least I'm saying it aloud. What was that? Somebody Mr. Kulicked me? Did I write something down wrong? Oh, I mean, my penmanship stinks. Well, I got all out of writing on the tablet practice. You guys are a bunch of boogers. And so this is maybe the kind of the tricky part here is just remembering that finding the other angle A is the supplement. So I have 33.8 and then 22.2. Okay. So that's not too bad, just using triangle sum theorems there. Ooh. Whoa, 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 whoa. Look what I did on that one. I goofed that up and typed in the angle from last problem. I thought the 22 looked weird. 10.2. Good job getting 10.2. You're welcome. Good. Maybe it's a new semester and it'll just be not as hard, right? Yeah. I think there's a little bit less like tricky detail this second semester than there is first semester.
That's why I struggle.
And then to find angle C, I'm going to do the law of sines again. 33. So I'll do sine of C over C equals sine of B over B. And then similarly, doing the same thing over here. If I cross multiply and divide, I get the values for each of these. And so I get here 10.8 and then 3.4. Feel okay on that there, Gaberoni? Yeah, of course. I'm really excited to hear that you're getting stuff right. That's good. That's good. You got them all wrong. I forgot to do that. I will get to doing that. Those of you that have me during community time, will you remind me during community time to post the odds? Thank you. Appreciate that. I know several of you I see again later today. All right. So let's move forward here. We're going to talk here about the law of cosines. So the law of cosines has 3 different versions of it. But really it's all the same. So these are the 3 versions of the law of cosines. So the way that I remember them is the side that's by itself is the one where the angle is in the cosine. You probably saw this in honors geometry. You could have saw it in the first. You could have seen it in the first semester or the first year of integrated. Also, I think that you do this. Yeah. When you look at this formula, though, what does it remind you of? Looks like the Pythagorean Theorem, right? Yeah. So what this actually is, it is a squared plus b squared equals c squared, and then we have this little correction factor to account for the part that we're not in a right triangle. So if you are in a right triangle, angle C would be 90 degrees, and the cosine of 90 is 0. So that correction factor just drops off the end. So this is really like a generalization of the Pythagorean theorem, which is kind of nice. So when we do the law of cosines, we can use it in a side-side-side situation or a side-angle-side situation. Those are the 2 situations where we'd want to use the law of cosines. Although we have to be a little bit careful in each of these situations what we do first. So in the side-side-side situation, we need to make sure that we find the biggest angle first. And in the side angle side, we want to find the smallest angle first. The reason we're doing that is we have to make sure that we just don't stumble into some weird ambiguous case situation where triangles might not exist, or we might end up with 2 possible answers and pick the wrong one of the 2. But if you follow that rule about which angle to solve for first, you can eliminate like any kind of ambiguity there. So not difficult to do that, but you have to kind of remember to do that, right? So that's really kind of an important safety tip there. All right, well, let's look at some examples. So we're going to solve the triangle with angle A of being 34, side B being 14, and side C being 17. Just real quick, I'm going to sketch out a triangle to make sure that I have a side angle side situation, not a side side angle situation, because maybe at first glance it's hard to tell. But if I look at the picture there, that's definitely side angle side, right? Because the 2 sides are the arms of the angle there. You also can get that by just looking at the values here, because you don't have angle A and side A. You know you have side angle side, right? If the two sides are different name than the angle, that's side angle side. If one of the sides is the same name as the angle, then it's side angle. Again, things that maybe aren't entirely clear at first glance. I just wanted to kind of point that out. Okay. So what are we going to solve for first? Got to find side A first. We don't have enough information to find anything else. So using the law of cosines, I have that a squared is equal to 14 squared plus 17 squared minus 2 times 14 times 17 times cosine of 34. And my suggestion to you is to type this all into one line on your calculator. So I'm going to do the square root of 14 squared plus 17 squared minus 2 times 14 times 17 times cosine of 34. Again, double check to make sure you're in degree mode. And I get 9507. Keep in mind when I type that in, I put the square root symbol in there. You want to make sure you're solving for c and not c squared. Common mistake I see students make is they forget the square root. All right, everybody cool there? Once we have the third side, now I can use the law of sines. So certainly I'm going to use A because it's the only one that I know both the angle and the side for. Now in the side angle side situation, I have to be careful about which angle I solve for next. So I want to solve for angle B or angle C next. B, how do I know angle B next? It's got to be smaller than angle C. How do I know it's going to be smaller? Because the side opposite it is smaller than the side opposite C. Very good. I think if you try to solve for C next, you'd end up getting a zero triangle situation and end up with an error on your calculator and probably be rather confused as to why it's not working. But that's the issue there. Okay, so let's cross multiply and divide and take the sine inverse. I'm going to do that all in one step. Is everybody cool with that? Oops, forgot to write sine inverse. And we'll call up the calculator. And again, when I'm doing all these things on the calculator, notice that I'm using that fraction command on my calculator. I like doing that mostly just because it'll saves me some aggravation trying to make sure my parentheses are correct. It's very easy to see if I've typed it into my calculator correctly because it looks exactly like it does on my sheet of paper. So there's 55.436. And now I just have one thing left to find, right? I just have angle C left. And that's going to be super easy. Because I can just do triangle sum theorem to get that. So I get 90.564. Any questions about what we did there? Okay. The only tricky part on this is just remembering to find that smallest angle first when it's time to solve for the angles, right? That doesn't mean the first thing you do is find the smallest angle. You have to find that side first. But when you start finding the angles, you have to be a little bit careful there. Let's do another example. So here we're going to solve the triangle with side lengths of 5, 8, and 10. I guess there's one other thing in the side situation we have to be careful of. I forgot to mention this earlier, so let's mention it right now. We should check to make sure if this triangle is possible. You can't just pick 3 numbers and be able to make a triangle out of it. How do we, what does the triangle inequality from geometry say? Does anybody remember that? No? The triangle inequality says that the sum of the 2 legs of the triangle must be greater than the hypotenuse. Is that true in this case? Yes. So definitely have a triangle here. Now, I would encourage you to make sure on these side situations you're checking that it's not above your sneaky jerk of a teacher to sneak a triangle that doesn't exist into the homework set or into a test or something. It's an easy check, but you got to remember to do it. Okay? Everybody's okay with that? Right? You just have to make sure that the sum of the legs is greater than the hypotenuse. It'll be it's not that hard to remember to do that though, because if it was not a triangle possible, as soon as you went to try to solve for the angle, you're probably getting an error at some point. Particularly if you're following the rule of finding the biggest angle first, you'd be getting an error right away. All right. So, finding the biggest angle first, which one, P, Q, or R, will be the biggest angle? R. Okay? So I can say 10 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of R. Everybody's okay here? All right, I'm going to solve for R and do this all in one step. I would encourage you guys to do the same thing. I see lots of mistakes that students make by combining like terms on these kinds of problems where they're not like terms to combine. In particular, I see students do 5 squared plus 8 squared minus 2 times 5 times 8 and write that as the coefficient on cosine. Not okay to do that. So what we'd want to do is we'd want to start by subtracting 5 squared and 8 squared from both sides, and then dividing by 2 times 5 times 8, and taking the cosine inverse of both sides, and that'll give me R. And again, I'm going to type that into my calculator in one line exactly as it's written. And if I use that fraction command, it's not difficult to get that in there. Okay. So I do that, I get 97.903. Everybody's okay there? To find my next angle, I could do the same thing. I could use the law of cosines again, or I can use the law of sines. Doesn't really matter. I'm going to use the law of sines. Does it matter which angle I solve for next? It does not. So let's see. We sine r over r is equal to sine of, let's do p over p. So if I cross multiply, divide, and take the sine inverse, all in one step, everybody's okay with me doing that? I hear no objections, so I'll assume that's okay. Again, I don't want to be skipping too much stuff in terms of the little algebra pieces if you're confused on something. But I also don't want to take like 25 minutes writing out all the nitty-gritty work for a problem like this when some of the algebra is kind of obvious. So that gives me 29.686. Oops. And then to find angle Q, I can just do 180 minus R minus P. Oops. And that gives me 52,411. 410. Probably should call it 411 because if I look at the other rounded answers, they should equal 180 degrees, my rounded answers. So we're going to stop here for today. For homework, I'd like you guys to work on 15 through 22.